Hello students, today's lesson is your first lesson in the factoring unit. So we're going to go over multiplying polynomial expressions, and in this first little bit we're going to talk about distributing. So I want to remind you about the properties of exponents when you're multiplying. When you're multiplying, if you've got coefficients, so coefficients are these numbers out front that are in red, 4 and 2. The coefficients you're going to go ahead and multiply, so you'll still multiply those like normal. So 4 times 2 is 8, so this is going to be 8. Now notice here that we have a base a, we have a squared, and we have a to the 5th. Whenever you have the same base, so a is the same base, you're going to add the exponents when you're multiplying. So a to the 2nd times a to the 5th would become a to the 7th when you're adding. And so this follows your properties of exponents that says anytime you have the same base with an exponent, when you're multiplying, you add those exponents. Okay, before we go much further, let's look at a couple of vocabulary terms. So the first vocabulary word is a term. A term is either a single number or a variable, or the product of several numbers of variables. Terms are separated by plus and minus signs in an expression. A monomial consists of one term. An example of that is just something that looks like this: 3x squared y. This is a monomial. Even though it has two variables, there's no pluses or minuses, and so that is considered one term. A binomial consists of two terms. So an example of that would be 2x squared minus 4. That's an example of a binomial. Again, we have a minus sign, and so that separates it into two terms, and so therefore it is a binomial. 3 terms is what we call a trinomial. So an example of a trinomial would be this: 4m squared n minus 3mn plus 2. Again, we have 3 terms, 1, 2, 3, so it is a trinomial. A polynomial consists of many terms, and so that could be anything, like as many terms as we want. Now, technically, all of these polynomials right here, these are also considered polynomials, but because they only have 1, 2, or 3 terms, then we tend to use the monomial, binomial, and trinomial. Polynomial just means it has many terms. It can have as many as you want. To distribute, that means to multiply by everything in parentheses. So we saw that a little bit when we were talking about multiplying polynomials. A variable is a symbol or letter that is used to represent a number. The coefficient is the number in front of the variable, and then like terms have the same variables with the same powers. So let's go ahead and start to work through some examples. So in these first 4 examples here, you're going to distribute and simplify completely. So if I distribute, that means I'm going to multiply the outside term by everything on the inside. So 4x times x gives us 4x squared, plus 5 times 4x is plus 20x. And that's all that you would do on this one. Now, we could also have a term at the end of parentheses, but we're still going to distribute that through. So the first term would now be 3z squared, and then 3z times negative 2 would give you that minus 6z. Okay, let's look at these next examples. negative z to the fourth is going to get distributed. And so remember, you have to add exponents when you multiply, so that would be a negative z. 4 plus 5 is 9, so negative z to the ninth. Then when we multiply a negative times a positive, that's going to be a minus 5. And then z right here, we assume that has a power of 1. So if I add those exponents, it would be z to the fifth. Let's look at this next one. Negative 3x times a negative 6x would give you a positive 18, because you want to multiply those coefficients, and then x times x is x squared. Negative 3x times negative 3 is a positive. 3 times 3 is 9, so it's a positive 9x. Okay, those previous examples were when we had a monomial multiplied by a polynomial. Now we're going to look at binomial times binomial. And so you've probably saw this in Algebra 1. You might have learned it using FOIL, which FOIL stands for multiplying the first terms, then the outside terms, then the inside terms, then the last terms. I'm going to show you a method that's called the box method. And the reason why I'm showing you this method is because it helps you keep it organized, but it's also going to help when we start to factor, which is work backwards. So to use the box method, what you're going to do is you're going to write one of your binomials on the left side. So let's just go ahead and put that first one, y plus 7. And the second binomial is going to go across the top, so y minus, whoops, that's a terrible minus, let me fix that, y minus 9. And this is kind of like the Punnett square from biology. You're going to multiply the length and the width of each of those boxes. So y times y is y squared. Y times negative 9 is a negative 9y. And then 7 times y is a positive 7y. And then 7 times negative 9 is a negative 63. And so then what you do is you look for like terms. Well, these are like terms. And so now I'm going to write my answer with combining those like terms. So I have y squared. 7y minus 9y is minus 2y. And then I'll have the minus 63. And so this is what the answer is from multiplying those two binomials together. This is the exact same thing as FOIL. I want to point out to you, this would be multiplying your first terms, right? Y times y. This would be multiplying your outside terms here, y times a negative 9. And this would be multiplying your inside terms, 7 times y. And then this would be multiplying your last terms, 7 times negative 9. So it is FOIL, it's just organized in a manner that makes a little more sense to some students. Okay, so let's try part B. If you want to pause the video and try this on your own, go ahead and do that, and then press play when you're ready to check your answer. All right, go ahead and check your answer. Hopefully you got the same thing that I did, and notice that you did need to combine that diagonal, and most of the time you will do that when you are using the box method. Okay, let's look at a couple more examples. We're going to use the box method again. Something I want to point out in this first example, x plus 5 squared. X plus 5 squared is taking x plus 5 and multiplying it times itself twice. So it really is x plus 5 times x plus 5. So let's go ahead and put those on the outside, x plus 5, x plus 5. And now let's multiply in. So x times x is x squared. X times a positive 5 is positive 5x. X times a positive 5 is positive 5x. And then 5 times 5 is a positive 25. And now let's go ahead and combine our like terms. So we'll have x squared. 5x plus 5x gives us plus 10x. And then plus 25. Notice that I did not end up with just x squared plus 25, because a lot of people, what they will try to do is they will try and distribute this to both terms, but then you're going to miss out on this middle term right here, so don't do that. All right, let's go ahead and look at this next one. Now this is a little bit more complicated. We have 3 terms, so a trinomial times a trinomial. Let's go ahead and put the trinomial, the first trinomial on the outside here. 2x squared plus 3x plus 5. And then across the top, we're going to put 4x squared minus 2x plus 9. And so let's go ahead and multiply these. So 2x squared times 4x squared gives us 8x to the 4th. Remember, you add those exponents. 2x squared times a negative 2x gives you a negative 4x to the 3rd, because this is assumed to be a 1 right there. And then 9 times 2x squared gives you plus 18x squared. Okay, then we're going to do 4x squared times 3x. That gives us 12x to the 3rd. 3x times a negative 2x gives you negative 6x squared. And then 9 times 3x gives you plus 27x. Okay, 4x squared times 5 gives you 20x squared. And then negative 2x times 5 gives you negative 10x. And then 5 times 9 gives you plus 45. Okay, now notice that when you do that, your diagonals are still going to be like terms, right? So we've got 8x to the 4th, that's going to be our first term. Then we're going to combine 12x squared minus 4x squared. You're just going to combine those coefficients by adding them. So that would give you a plus 8x to the 3rd. Then we've got squared, which is this diagonal. 18 minus 6 gives us 12. 12 plus 20 gives us 32. So that would be a plus 32x squared. Then we have our x's here. Positive 27x minus 10x would give us plus 17x. And then we have plus 45. So you're going to see that this box method helps a lot when you have lots of terms that you're having to multiply. All right, for this last example, we've got a word problem. It says the width of the rectangle is x minus 1, and the length is 2x squared plus x minus 3. Write an expression for the area of the rectangle. So if I label my rectangle right here that's in yellow, the width is x minus 1, and the length, oh, sorry, I put that in the wrong position. Let me fix that. Okay, let's try that again. The width is x minus 1, and the length is 2x squared plus x minus 3. All right, and they want us to find the area. Well, if you remember, area of a rectangle is just length times width. So that means we're going to multiply that x minus 1 times 2x squared plus x minus 3. So let's go ahead and use this box that I have set up here. We're going to put the binomial on this side, x minus 1. We're going to put the trinomial across the top, 2x squared plus x minus 3. And go ahead and multiply inside the box. So 2x squared times x is 2x to the 3rd. X times x is a plus x squared. And then negative 3 times x is negative 3x. Then we have 2x squared times negative 1, which is a negative 2x squared. We have x times negative 1, which is negative 1x. And then negative 3 times negative 1 is positive 3. If we combine our like terms, again, we have our diagonals that can get combined. So 2x to the third is what we would have first. Then when we combine negative 2x squared plus 1x squared, that gives us negative 1x squared. Then we have negative 3x plus a negative x, that gives us negative 4x. And then we have plus 3. So the area of this rectangle is this polynomial right here. All right, hope you understood everything. Please come to class with your notes filled out. We can go over some more examples.